Title of our project is Development of Gesture-Driven Robotic Arm in Medical Field. Existing system. In this existing system, the person or user has to carry the accelerometer. As the accelerometer moves, the robotic arm also moves. A sensor is connected to the accelerometer and the robotic arm. This sensor senses and captures the movements as parameters and makes the robotic arm to act accordingly. Drawbacks. The drawback in the existing system is that the user always has to carry the accelerometer whenever the robotic arm has to be moved. The distance between the accelerometer and the robotic arm should be maintained at a very small distance. Beyond this distance, the sensors cannot capture the signals. In the proposed system, accelerometer inputs used in existing system are replaced by gesture inputs, which is made possible through the camera. Here, distance is not a limiting factor, and we here made the achievable distance of 20 meter between transmitter and receiver with the help of ZIGBEE technology, and distance can be further extended using repeaters. The proposal of a project is demonstrated through an animated system. In this system, the gesture of the human hand is captured by the camera and the video signal of camera is fed to the PC. Then the video signal is converted as parameters with the help of LABVIEW and then transmitted by ZIGBEE transceiver. In this section, ARM7 microcontroller is used for storing programs of predefined gestures. In the another section of the system, the transmitted parameters are captured by ZIGBEE transceiver and these values are compared with the predefined program of ARM7 microcontroller, from which appropriate gesture is chosen and this gesture is imitated by robotic arm. Since the robotic arm is to be applied in the medical field, in this section, 5 vital parameters of the patient such as pressure, temperature, respiration rate, pulse rate, ECG are monitored. In case of any imbalance in the patient's parameters, the alarm in the other section of the system will ring, which is connected to the ARM7. A wireless camera is placed near the robotic arm through which all of its movements are monitored by the physician at the other end. This is the major advantage of the gesture-driven robotic arm, where even in the absence of the specialist, a robotic arm can handle the patient with the guidance of the specialist or surgeon at the far distance. The functionality of the robotic arm can be extended for 360 degree of freedom so that it can be used as prosthetic arm. Further, it can be applied in bomb squad, medical, military, hazardous areas, and mines. Objective of this project is to integrate the robotics and biomedical sectors by which a robotic arm is trained capable of performing minor operations and provides assistance to doctors even in his absence. Initially, different gesture images of the person or user's arm is captured using camera and stored. Here we have included 32 gestures which is represented in binary format. LabVIEW software is used in the project to translate images to parameter and vice versa. Those predefined images are stored in microcontroller, and through ZIGBEE transceiver these parameters are transmitted to robotic arm and received by user. This is the mechanical prototype of robotic arm, and the camera is used to sense the gesture image of doctor. This module includes temperature sensor, heartbeat sensor, microcontroller, and ZIGBEE, which acts as transmitter. This is another ZIGBEE unit which acts as receiver, and glucose level sensor is also included. In this block diagram, coding is generated to recognize the image, translate image to parameter, and also for all the sensors. Training of robotic arm to analyze and recognize is the significant feature of this project. Thus, the arm can perform the gesture of doctor by comparing the transmitted gesture values with predefined gesture. This is made possible by LabVIEW through Vision module. Thus, this robotic arm is to be applied in medical sectors where the arm can play the role of specialist even in his absence. Next, we have included the patient monitoring module, which includes temperature sensor, heart rate sensor, and glucose level sensor. For safety measures, we have included two units since robotic arm handles patient. One is wireless camera, which is placed near the robotic arm to monitor the performance of the arm, which can be seen by the doctor or user at the other end. So in case of the robotic arm performs any unsupported gestures, the doctor can stop the process immediately and intimate the patient details to nearby specialists to take care of the patient. The main advantage of this project is since we are giving gesture inputs to robotic arm through camera and transmitting it through ZIGBEE wireless technology, the transmitter and receiver distance is achieved up to 20 meter and it can be extended using repeaters. For further enhancement, we are working on the robotic arm to perform tasks like cutting and coagulation.